The largest telescope ever flown launched into deep space on Christmas Day, 2021. The James Webb Space Telescope has already lived up to its hype as the most advanced space observatory ever launched. Since its deployment, it has provided some of the most breathtaking and scientifically provocative images of our universe. One image in particular, a haunting deep-field capture of what appears to be a chaotic, uncharted region of space, has ignited a storm of intrigue, awe, and speculation. It wasn't just the public who felt the stir. Even those who have long stood as voices of scientific reason were moved. Among them, Bill Nye, the ever-enthusiastic science communicator who has spent decades educating the world on space physics and critical thinking. Finally, he stepped into the conversation. His reaction, long anticipated by fans and skeptics alike, marked a notable moment in the dialogue surrounding the Webb telescope's discoveries. Before we start, smash the like and subscribe buttons for more updates. The image in question was released as part of Webb's Deep Space Observation campaign. Unlike its predecessors, this telescope has the ability to peer not only farther into space, but deeper into time, capturing light that has traveled across billions of years. What appeared in this image was not merely a snapshot of distant galaxies or nebulas, but a tangled web of cosmic structures and phenomena that defied expectations. Several researchers had anticipated a high density of early universe galaxies, but the clarity and density presented in this image painted a picture that was almost too rich, too intricate to immediately make sense of. It wasn't just the quantity of galaxies, but their peculiar, irregular formations that demanded closer scrutiny. There was something deeply unsettling about the photograph. Nestled among the elongated spirals and elliptical galaxies were strange thread-like structures and what some initially speculated might be protogalaxies caught in the act of forming. These weren't mere specks of light on a black canvas. They shimmered with energy, twisted like cosmic filaments, and sprawled across the frame in a way that broke conventional patterns. To the trained eye, this was no ordinary formation. Astrophysicists pored over the data, trying to match what they saw with simulation models of the early universe. The match was loose at best. What appeared in Webb's field of vision suggested either a radically faster rate of early galaxy formation than expected, or some other less understood process at work. Bill Nye, typically a measured voice in the face of new scientific data, found himself deeply captivated by the image. His reaction wasn't sensationalist, nor was it overly skeptical. Instead, he approached it with a raw and sincere sense of wonder, a tone that resonated with a global audience. For someone who has spent his career boiling down complicated scientific ideas into digestible, engaging content, this moment was different. There was no easy analogy to explain away the alien beauty of the Webb image. It was, in essence, a puzzle delivered by the cosmos itself, a riddle written in infrared light. What made Nye's reaction so compelling was the way he acknowledged both the scientific and philosophical implications without attempting to offer false certainty. He didn't provide answers because the image didn't come with them. Instead, he reflected on the sheer scale of what humanity was witnessing. It wasn't just about seeing farther, it was about seeing differently. The structures caught in that Webb image weren't just faint glimpses of ancient light. They were clues to the very architecture of space-time, woven into the fabric of a universe we barely understand. Scientists around the world debated the implications. Some suggested that what we were seeing could indicate alternative models of cosmic inflation. Others speculated about dark matter distributions and the role of exotic matter in shaping such formations. Still others considered the image in the context of multiverse theories, positing that these unusual cosmic threads might be gravitational echoes or scars from dimensional interactions. Each theory, no matter how bold, was an attempt to explain the inexplicable. The image forced cosmologists to reconsider assumptions about the uniformity and symmetry of the early universe. From a scientific standpoint, the most disruptive element of the image may have been its defiance of scale. Several galaxies appeared to be forming in dense clusters far earlier than models had predicted. The timeline of star and galaxy formation, previously thought to follow a predictable curve of cooling, collapsing, and coalescing, now seemed prematurely accelerated. If galaxies of that complexity were indeed forming that early in the universe's history, then everything from the rate of matter accumulation to the behavior of gravity in the early universe may need to be recalibrated. Nye's commentary didn't dive into the weeds of astrophysical equations, but it did highlight what makes this moment so profound. This wasn't simply about cosmic cartography or expanding our galactic senses. It was about being confronted with a truth that slipped just beyond our grasp. A reality so vast and ancient that our finest instruments still render it in incomplete terms. He spoke to the emotional weight of such a revelation, the unsettling beauty of the unknown, the humility that comes from glimpsing forces that have shaped everything we know. For the general public, the image took on a life of its own. Artists reimagined it in surreal renderings. Philosophers weighed in, discussing the metaphysical implications of seeing structures that predate our solar system by billions of years. Educators scrambled to incorporate the image into their curriculum, while spiritual thinkers contemplated its resonance with age-old questions about creation, existence, and purpose. It wasn't merely a scientific event, it was a cultural one. The most persistent thread in all of this was awe. Not fear, not confusion, but a deep, stirring sense of awe. Nye tapped into that. He didn't claim to know what the image definitively meant, but he did emphasize the importance of continuing to look, to ask, to probe deeper. The Webb telescope, in his view, wasn't just an engineering triumph. It was a philosophical tool. With every new image it captures, it invites us to step beyond the confines of everyday perception and confront the extraordinary. It shifts our perspective, stretching our imaginations to accommodate possibilities previously unthinkable. There was also a distinct emotional weight to the moment. Nye, whose career began in classrooms and TV studios, found himself reacting not just as a scientist, but as a human being. There was wonder in his voice, but also something softer, reverence. The kind of reverence one might feel when standing on the edge of the Grand Canyon or hearing a piece of music that stirs memories buried deep within the psyche. The Webb image wasn't just data, it was an experience, a moment of encounter with the cosmic unknown. The impact on younger generations cannot be overstated. For students who had grown up with Nye's energetic lessons on Newton's laws and planetary orbits, seeing him respond with such solemn amazement bridged the gap between science and sentiment. It made the pursuit of knowledge feel more human, more accessible. In that moment, science wasn't about solving, it was about seeking. The implications of the Webb image extend far beyond the frame. It challenges our very sense of cosmic chronology. If the early universe was more complex and active than previously thought, then our models for its evolution must be revised. It affects how we think about time, space, and causality itself. It may even shift the way we search for life beyond Earth. If the structures captured in the image are typical of other regions of space, then the potential for habitable environments, planets, even microbial life, might be far broader than previously assumed. In the context of space exploration, the image adds urgency to humanity's quest to move beyond Earth. The more we learn about the universe, the more apparent it becomes that we are not its center. We are not even close to understanding its edges. The Webb image underscores how much more there is to learn, to see, and to feel. It reminds us that our planet, our solar system, our galaxy are all threads in a much larger tapestry. What Webb has revealed, and what Nye so eloquently acknowledged, is that the universe is not a static backdrop, but a living, changing entity. The structures in that image may be billions of years old, but they are still influencing the shape of reality today. Gravitational waves ripple across the void, bending space and time. Black holes consume stars and exhale radiation. The universe, in all its vastness, is active. As science marches forward, the tension between certainty and curiosity grows more dynamic. Nye's reflection serves as a gentle reminder that knowledge isn't always about finding definitive answers. Sometimes, it's about finding better questions. The Webb image has sparked 1,000 of them. Each strange filament and glowing arc is a story waiting to be told, a narrative encoded in light traveling unfathomable distances to reach our fragile blue dot. To see Nye respond with such wonder is to witness the human spirit in its most genuine form, not the spirit of dominance or conquest, but of inquiry and reverence. The Webb telescope may be a machine, but what it captures transcends technology. It brings us closer to the truth of our place in the cosmos. Not central, not dominant, but deeply connected. The structures we see are our ancestors, in a way, stellar nurseries and galactic cradles that preceded us by eons, yet somehow still reach us, still influence us. The moment Nye broke his silence wasn't a revelation of facts, but of feelings. He voiced what so many silently felt: awe, curiosity, and a renewed sense of purpose. The universe had spoken in light, and for once, humanity listened, not with conclusions, but with wonder. As we continue to analyze that image and the ones to come, we do so with eyes wide open, reminded that the cosmos still holds its secrets close. But for a moment, just a moment, it let us in. The haunting image captured by the James Webb Space Telescope did more than just present new cosmic data. It reshaped the collective mindset of humanity in a profound and lasting way. As the image circulated, revealing a tumultuous, intricately detailed sector of the universe, it became clear that what Webb offered wasn't just science. It was a moment of realization, a silent cosmic communication. The very act of observing such a region, so far, so alien, so fundamentally untouched by the human story, forced a reconsideration of the foundations upon which astrophysics, philosophy, and even identity are built. With instruments capable of peering into the deepest stretches of time, Webb unearthed a part of the universe where standard cosmological assumptions seemed to crack. The image wasn't merely a static record. It was a dynamic confrontation with the universe's past and our future understanding of it. The strange light signatures, unusually formed clusters, and curious spatial relationships challenged even the most seasoned astronomers. Data streamed in, but interpretation lagged behind. The configuration of the filaments and the spectral frequencies suggested energies and events that weren't accounted for in current models. The initial scientific response included a surge of theoretical recalibration. Research teams scrambled to simulate what might produce such high-density clusters and chaotic motion so early after the Big Bang. Perhaps there were forces or particles influencing cosmic expansion and early structure formation that had yet to be observed directly. Dark radiation, interactions among hypothetical early massive particles, or even new variants of quantum gravity theories. Every serious scientist understood, a single anomaly does not overturn physics, but it does invite an opening. That opening widened with Webb's precision. For Bill Nye, a step forward at this junction was not a typical science media moment. It signaled a turning point in how information bridges from raw discovery to cultural absorption. His focus has always been on popular engagement, often guiding public understanding through playful, yet accurate explanations. But this time, his tone carried a solemnity, a subtle shift. He didn't perform science. He responded to it. The Webb image didn't require a breakdown of scientific principles. It demanded a reckoning with cosmic immensity, with the fact that we're gazing into a period of the universe never before seen in such high fidelity. The silence Nye had maintained until that point was noticeable. Scientists had weighed in with technical papers and cautious predictions. The media, as always, grasped for sensational headlines. But Nye's delay created anticipation. It wasn't about withholding insight. It was about honoring the depth of what the image revealed. When he finally offered his reflection, it echoed a collective sentiment. This wasn't something to rush past, explain away, or repackage into a digestible soundbite. It was something to behold. The implications of the image stretch far beyond our current comprehension. Time, as we measure it, is a human construct tied to our movement through space. Yet this image revealed regions of space in their most primal states. Long before Earth had formed, before our sun had ignited, before even the elements of life as we know them had coalesced. The light from these ancient structures traveled billions of years only to land on a mirror engineered by human hands. In doing so, it created a bridge, not just across space, but across eras of existence. What further astounded experts was the apparent contradiction between the image's vibrancy and the theoretical expectations of a dim, relatively uneventful early universe. This was not the flat cosmic soup once imagined. There were patterns, interactions, and chaos. The gravitational clumping, the elongated luminous formations, and the unorthodox alignments all pointed to a complexity that suggested perhaps the laws of physics, though consistent, express themselves differently in certain extreme environments or epochs. For physicists, this raised the tantalizing possibility that the constants we consider fixed, such as the gravitational constant or the rate of universal expansion, might vary subtly over cosmic distances or under specific conditions. If that were the case, the implications for everything from particle physics to our understanding of entropy would be vast. The Webb image may not be proof of such variations, but it plants the seed. It opens the door. Even more provocative were the potential implications for the search for extraterrestrial intelligence. The Webb image wasn't directly related to life-bearing planets, but it did show that the cosmos might mature much faster in certain pockets than previously believed. If galaxies form earlier, then stars stabilize earlier. If stars stabilize earlier, then planets could cool and support chemistry far earlier than anticipated. The so-called habitable window might stretch back billions of years further than we assumed. In that context, civilizations, if they ever emerged, could predate us by unimaginable spans. This shift in thinking turned a purely astronomical observation into something sociologically and philosophically significant. How does a civilization reckon with the fact that it is likely not the first, nor perhaps the most advanced, nor even especially unique? Bill Nye, in acknowledging the magnitude of the image, indirectly brought these existential questions into mainstream discourse. He didn't speculate about aliens or lean into science fiction tropes. Instead, he invited contemplation about the timing of human emergence, about the fragility of life in a vast ancient universe, about the dignity of continuing to explore even without guaranteed answers. Moreover, the image served to upend our sense of spatial scale. These weren't just faraway galaxies. The distances involved were so extreme that the structures were seen not as they are, but as they were when the universe itself was in its infancy. It is not an image of the present, but of a long-dead past. In observing it, we are not so much exploring space as we are engaging in a form of celestial archaeology. The Webb telescope acts as both a machine and a metaphor, a mirror aimed at the cosmos that reflects back not just the distant universe, but our yearning to understand it. As the image continued to circulate, it found its way into classrooms, lecture halls, and dinner table conversations. Its color palette, rendered in enhanced infrared, was both beautiful and disorienting. To the untrained eye, it was a riot of light and shadow. To the astronomer, it was a data field alive with anomalies. But to the philosopher, it was something else entirely, evidence that reality is stranger, more layered, and more filled with unexplainable grandeur than even our most advanced mathematics can capture. Bill Nye's contribution wasn't a calculation. It wasn't a hypothesis. It was a reflection, which in moments like this carries just as much weight. In a time when scientific discourse is often burdened by urgency, climate models, biomedical crisis, technological ethics, the image presented something rare, a moment of deceleration, of pure, unfiltered astonishment. In that sense, Nye's response was almost literary. He wasn't attempting to explain the image. He was living in its shadow, marveling at its depth, allowing its implications to settle into the human psyche without rushing to fill the silence it created. Notably, this image also reopened conversations about the human instinct to explore. Historically, exploration was physical, sailing across oceans, climbing mountains, building satellites. But Webb represents a new kind of exploration, one of perception, of temporal reach, of cognitive boundary pushing. It doesn't carry astronauts. It carries our sight itself. It extends our gaze into epochs that have been silent since time began. And as Bill Nye reminded us, this is what science does best. It extends the limits of what it means to be aware. In the months following the release of the image, ripple effects coursed through academic disciplines. Cosmologists revisited the assumptions underlying their simulations. Mathematicians began working on new models of space-time curvature that could account for what Webb revealed. Even theologians found themselves drawn into the fold, considering what it means to live in a universe where the beginning is more complex than previously thought. The image didn't create dogma. It opened up inquiry, the highest form of intellectual engagement. And then there's the matter of legacy. The Webb telescope will send back many images, but this early, jarring revelation, may stand as the moment where the paradigm began to shift, where theory began to chase observation again instead of the other way around. Bill Nye's engagement with this image wasn't just commentary. It was an acknowledgement that science doesn't always march forward. Sometimes it stares upward in silence, stunned by what it sees. Artists responded as well. Painters, digital illustrators, even choreographers attempted to interpret the cosmic threads through motion, color, and abstraction. Museums and planetariums redesigned exhibits to feature immersive renditions of the Webb image. It wasn't just about space, it was about perspective. Suddenly, humanity had a new image to anchor its imagination, a portrait of the unknown glimpsed with unprecedented clarity. Educational platforms saw a surge in interest in astronomy and physics. Students who had never thought much about dark matter or early galaxy formation were now drawing sketches, asking questions, and running simulations in classrooms and on home computers. In that way, the image wasn't just an astronomical triumph, it was a societal one. Nye's enthusiasm lit the torch for a new generation, reminding the world that even in a digital age overloaded with information, some images can still stop us in our tracks. As the analysis deepens and the implications widen, it becomes increasingly clear that this image was not a discovery in the traditional sense. It was a challenge to our models, our minds, and our imaginations. It reminds us that the universe is not only vast, but intricately detailed in ways we are only beginning to comprehend. In recognizing that, Bill Nye captured the essence of what scientific wonder is really about, not dominance over nature, but reverence before it. So the Webb image endures not just as a scientific artifact, but as a cultural touchstone. It symbolizes the moment when humanity realized that the early universe was far from simple, far from quiet. It was active, complex, and fundamentally beautiful. And in responding to it, Nye helped us understand something essential, that the pursuit of knowledge is not just an intellectual endeavor, it is a human one. It is the act of seeing farther, thinking deeper, and feeling more profoundly connected to everything that came before us and everything that might come after. What comes next will no doubt build on this foundation. New images will reveal even stranger phenomena. New instruments will probe deeper still. But this moment, this first confrontation with a past so vividly alien and so elegantly captured, will remain. It marks the beginning of a new era, not just in astronomy, but in human awareness. And it was shaped not just by a machine orbiting far from Earth, but by the people who dared to interpret what it revealed. People like Bill Nye, who knew that sometimes the most powerful thing science can offer is not an answer, but a question that changes everything. The James Webb Space Telescope's shocking image, chaotic, brilliant, and eerily alien, emerged as a cosmic cipher, a moment when the universe, unprompted, revealed something not only unexpected, but nearly unfathomable. In the weeks and months that followed, the image transformed from an astronomical release into an existential reckoning. It became an intellectual crucible across disciplines, spurring new questions about not only the mechanics of cosmic structure, but also the nature of perception, human limitations, and the boundaries of what it means to know something. One of the most startling aspects of the Webb image was its unambiguous clarity. Prior deep-field images captured by the Hubble Space Telescope had hinted at the distant past, but those snapshots, while groundbreaking in their own right, were softer, blurrier, and filtered through more noise. Webb's infrared sensitivity, combined with its enormous mirror and precision instruments, gave us our first true glimpse of the early universe with startling fidelity. This wasn't a faint whisper, it was a chorus. The ancient light, cooled and stretched by the expanding universe, arrived not diluted but singing, shouting its presence across time and void. Every strand in the image suggested some interaction, mergers, collisions, entanglements of gravity and matter, that hinted at a level of violence and volatility no one had anticipated in such a young universe. The fundamental assumption that the early cosmos was a smooth, gradually evolving expanse of hydrogen and helium now seemed oversimplified. The Webb image didn't just show stars and galaxies. It showed motion frozen in light, evidence of great cosmic events unfolding at a pace previously considered impossible. One structure in particular, a filament of mass that curled like a strand of DNA across millions of light years, captivated theoretical physicists. Its shape appeared too regular, too tightly woven to be a coincidence. Its gravitational lensing effects on the background light hinted at mass densities that couldn't easily be accounted for by visible matter alone. This reignited interest in exotic matter candidates. Was this filament evidence of a form of dark matter we had not yet imagined, one that clumped and structured itself in dynamic ways? Or was it possible that some early quantum effects had macroscopic consequences during the universe's rapid inflation phase? The philosophical implications spiraled from there. If this image represented a fundamental flaw in our chronology of cosmic development, what else might we be misreading? The light that arrived from those deep reaches told a story. But as with any ancient manuscript, the translation is fraught with interpretation. We don't just observe the universe. We filter it, model it, translate it through equations and theories. If the foundational assumptions were off, even slightly, then our entire timeline of reality might need revision. Enter the speculative but increasingly discussed idea of variable cosmological constants. While it may sound esoteric, the notion that constants such as the speed of light, the gravitational constant, or the cosmological constant might have evolved over cosmic time is being taken more seriously. The Webb image does not confirm such ideas, but it nudges open the door. If something truly fundamental is shifting, something we've long considered fixed, then not only physics but metaphysics is called into question. This isn't just academic posturing. The realization that the laws of the universe might be context-sensitive has cascading consequences. Consider our technological assumptions, GPS systems, nuclear energy, even our understanding of materials are built on principles believed to be universally stable. What if those are only locally true? What if the rules change across space and time? In classrooms and scientific forums, a new wave of inquiry began. There was a hunger not just to understand the image, but to locate ourselves within its implications. For students just beginning their journey into science, the image was a baptism into the mysteries of a universe less deterministic and more poetic than textbooks had suggested. Professors found themselves encouraging more open-ended questions, urging students to theorize freely, embracing the tension between uncertainty and exploration. Psychologically, the image struck a chord because it reminded us that the cosmos isn't static. We often speak of the universe in grand, majestic terms, expansive, beautiful, ancient. But the Webb image revealed a younger, wilder universe still churning in the throes of its birth pangs. It wasn't serenity, it was upheaval. Star-forming regions flared in violent plumes. Galaxies seemed to collide with reckless abandon. There was movement, energy, and conflict. The universe we saw was not old and wise. It was young and aggressive. Such realizations bleed into the way we perceive our own planet. Earth, often viewed as precarious yet exceptional, now seems like a quiet backwater compared to the cosmic storms unfolding just beyond our reach. The image made Earth feel both more vulnerable and more sacred. In a universe where chaos seems the norm, the stable, life-bearing conditions of our home become all the more miraculous, not as a product of destiny, but of astronomical chance. This dual awareness of insignificance and preciousness found its way into cultural conversation. Artists began creating works that juxtaposed human life with deep cosmic phenomena. Poets wrote of stars being born in violent waves as humans whispered love songs into the dark. Musicians used sonified data from the Webb image to compose immersive soundscapes that allowed listeners to hear the shape of ancient light. This wasn't just data, it was muse. At research institutions, attention turned to reconciling the Webb data with previous findings. Could the unexpected density of structure formation be harmonized with earlier cosmic microwave background measurements? Or did this image signal a crack between early and late universe physics? Several teams proposed multi-phase inflation models, where the early universe underwent not one, but multiple bursts of exponential expansion, each governed by a different set of physical rules. These models remain controversial, but the Webb image breathed new life into them. Another stream of research considered the implications for time itself. The cosmic web as displayed in the image suggested nonlinear growth patterns, like veins branching through a growing organism. If time itself is a dimension that stretches and warps with mass and energy, then the image might also be interpreted as a map of how time flows across the universe, not evenly, but with eddies, loops, and turbulence. A universe where time is elastic, not uniform. Theologians and spiritual thinkers didn't stay silent either. For them, the image represented a deepening of mystery rather than a challenge to belief. In the image's overwhelming complexity, they found a renewed invitation to contemplate the sacredness of the unknown. Whether one views the universe through a secular or spiritual lens, the image demanded humility. It insisted that there is still much that lies beyond comprehension, and in that recognition, many found a kind of peace. Meanwhile, educators seized the opportunity. Curriculums were updated. Special modules were created around Webb's image, encouraging students not only to study the known facts, but to engage in speculative science.